in this problem, we are going to find the roots of the function g of z equals to z to the power of 6 plus z to the power of 4 plus z squared plus 1. So the roots of this kind of function is known as the roots of unity, because the roots of unity are the roots of a special kind of function. So if you have a function f of x equals to x to the power of n minus 1, the n roots are going to be e to the power of 0, e to the power of 2 pi I divided by n, e to the power of 4 pi I divided by n, and so on. So our goal will be to write the function g of z in the form of the function x to the power of n minus 1. So to do this, we will need to first manipulate the equation. The polynomial is a geometric series, and the common ratio is z squared. So to get it into the form of x to the power of n minus 1, we could first multiply both sides of the function by z squared, then do some subtraction to get into the form that we want. So z squared times g of z equals to z to the power of 8 plus z to the power of 6 plus z to the power of 4 plus z squared. If we call this equation as 1, this equation as 2, then equation 2 minus equation 1 will give us z squared minus 1 times g of z equals to, when you subtract this, notice that this part and this part, z to the power of 6 plus z to the power of 4 plus z squared cancels out, leaving us with z to the power of 8 minus 1. So we have written it in the form of x to the power of n minus 1, but we are not done yet. We have to isolate the function. But before we can divide both sides by z squared minus 1, we have to split it into cases. So case 1 is z squared minus 1 equals to 0. So we have, there's going to be no solution, because first of all, we cannot move this to the other side because we cannot divide by 0. And then from here we have z squared equals to 1, so z equals to plus minus 1. But then when z equals to plus minus 1, you plug it in, you find that the value of g of z is going to be 4, which is not going to be a root. So we have case 2. Z squared minus 1 is not equal to 0. So z is not equal to plus minus 1. Then we can divide both sides by z squared minus 1. So we have g of x equal to x to the power of 8 minus 1 g of z equals to z to the power of 8 subtract 1 divided by z squared minus 1. So to have z of z equals to 0, we need z to the power of 8 minus 1 equal to 0, because if the numerator is 0, then as long as the denominator is not equal to 0, which is the case in this case, then we have it to be a root. So g of z equals to 0. And then to find the roots of z to the power of 8 minus 1, we have the roots are going to be e to the power of pi I over 4. And notice that we did not involve e to the power of 0 because e to the power of 0 equals to 1. And we already established the case that z cannot equal to plus minus 1. So then we can just simplify. And in this case, there's going to be 8 roots of unity because there's going to be 8 roots of unity because n equals to 8. And then we can just simplify to get e to the power pi over 4, e to the power of pi I over 2, e to the power of 3 pi I over 4, e to the power of 5 pi I over 4, and e to the power of 3 pi I over 2, and e to the power of 7 pi I over 4. And that is how you find the roots of this function.